Hi everyone, I'm Adam, and in this problem we're going to be solving the quadratic equation tangent squared x plus 3 tangent x plus 1 using the quadratic formula and finding all solutions on the interval from 0 to 2 pi. So starting, let's go ahead and review our quadratic formula. So for a general quadratic equation of the form ax squared plus bx plus c equal to 0, our quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So we can apply that to our equation over here, treating the argument tangent just like the argument x over here. So we can solve this. So tangent x is going to be equal to, first looking at our coefficients, we have a 1 times tangent squared in front, b 3 times tangent, and c equal to 1 on the end. So tangent of x is equal to negative b, or negative 3, plus or minus the square root of b squared, 3 squared, minus 4 times a, which is 1, times c, which is 1 on the end, all over 2 times a, or 2 times 1. Okay. So what we have here with our plus and minus is actually two solutions. So we'll write this separately. The first solution is tangent x equal to negative 3 plus the square root of 3 squared, which is 9, minus 4, gives us the square root of 5, all over 2 times 1, which is 2. Now if we plug this into our calculator, we can approximate this as negative 0.3820. So that's our first solution. And the second solution is tangent of x equal to negative 3 minus the square root, everything underneath, 3 squared minus 4, which again is 5, all divided by 2. And this can be approximated by plugging into our calculator as negative 2.6180. So that's what tangent is equal to. Now to solve the equation, we want to find what x is equal to, or the angle. So in doing this, now normally we would approach this by looking either at the unit circle or what we know about our regular values. So with tangent, we don't know what angle gives us something like negative 0.3820. We know nice values like 1/2, square root of 3 over 2, and things like that. So here we're going to employ the inverse tangent function. So x is going to be equal to inverse tangent of this part, negative 3 plus the square root of 5, all divided by 2, which can be approximated as negative 0.3649. And for the solution x on the right side, x is equal to tangent inverse of negative 3 minus the square root of 5 divided by 2, which can be approximated as negative 1.2059. Okay, so let's take a step back. We've done a lot of work here. What are we looking to do to begin with? We want to solve the quadratic equation on the interval from 0 to 2 pi. That means find all angles or values x within that range. What we have is x equal to negative 0.3649 and negative 1.2059, neither one of which is in our interval 0 to 2 pi. So what can we do? Well, to take a look at this, we're going to look at the graph of tangent. We'll draw in our tangent graph. Okay, so once again, what do we have? We have the solutions x equals to negative 0.3649 and negative 1.2059. And we want solutions which are within the interval from 0 to 2 pi. So namely, x values between 0 and 2 pi here. So let's start with what we have. So we have the x value, negative 0.3649, which is close to 0. And looking at that, we see that has a y value the y value, or tangent value, of negative 0.3820. So what does that tell us? If we look at this y value, we see we have two more y values inside this interval from 0 to 2 pi. And what we care about specifically is the x values giving us those. So how can we find those? Well, what we're going to use is the fact that we know about the graph of the tangent function has period pi. So if I go for my x value, negative 0.3649, and add pi, I get to my next x value. If I add pi again, I get to the other one. So that's what we're going to have. So let's write those down for now. So we're going to have solution, where x being approximately equal to our value negative 0.3649 plus pi and negative 0.3649 plus another multiple of pi, or plus 2 pi. Now let's take a look at the other solution we had. We're pretty much going to do the same thing, taking the value x approximately equal to negative 1.2059, which is going to be a little bit closer to negative pi over 2. And so taking a look at that, we have the y value or tangent value approximately equal to negative 2.6180. Now, of course, looking in the interval from 0 to 2 pi, we have the y values here and here. And so what we care about is specifically the x values, which will give us those solutions. So once again, using the fact that the tangent function has period pi, if we take the value negative 1.2059 and add pi to it, we get the solution here. Add pi again, we get the solution here. So we can write that down as x approximately equal to our x value negative 1.2059 plus pi and negative 1.2059 plus another multiple of pi, or plus 2 pi. So what we want with our solution is to approximate it to 4 decimal places. So what we'll go ahead and do is take each of our values respectively, adding pi and 2 pi, and round those. So taking our calculator, so first, negative 0.3649 plus pi, we get 2.7767, and negative 0.3649 plus 2 pi, we get 5.9183. And the next set of solutions, taking x negative 1.2059 plus pi, we get 1.9357. And lastly, negative 1.2059 plus 2 pi, we get the value 5.0773. So there is our 4 solutions rounded to 4 decimal places. Thank you very much.